Hello everyone, welcome back to the another session and principles of programming languages. So in the last video, we left with one topic which is coroutine. So as time is not sufficient to make in the same video, we were splitted this topic into the next video. So now this is the last topic. Coroutine is the last topic of third unit. So this video will be going to cover about two things. One is about the differences in between closures and coroutines. Second is what exactly a coroutine. Fine, those two things we'll cover in this video. Now, so let's see about what do you mean by the closure respective to coroutine. Now we'll find the differences in between both coroutine and closure. So closure is what we were discussed in the last video. Closure is a subprogram and the subprogram which is defined in the referencing environment. The third point about closure is, we'll call that subprogram in any arbitrary place. These are what three features of closure. Now, coroutine is what? It is subprogram and it will be having only one entry point. Closure will be having many things that you can find here. So, I told you about closure. Now, let's see. We'll write the differences so that I can clear your doubts if you have any. I am talking about closures, I am talking about coroutines. Closure and coroutine both are subprograms. The difference in between these two is what? Closure basically it is a thing what is defined in a referencing environment. Now we'll define a closure in the referencing environment. Coming to coroutine, coroutine is something like of called-callee procedure. Let's say master-slave relationship. Rather than the master-slave relationship, called-caller subprogram relationship will be going to see in the coroutine. And it will be having multiple entry points. Now the next point is what? You can call this subprogram from any arbitrary place. From any arbitrary place. The fourth point is what? Now here coroutine is called by the coroutine itself. Fine. Now the fourth point is what? We can use these closures in only nesting subprograms and coroutines you can use anywhere. So these are what the fundamental differences when you put together closures and coroutines. People feel that both are same. No, both are different and the difference is what I have mentioned over here. Now let's see about here. We'll go back to the previous example once again. Now we defined one function. Let's clear this differences so that you can write neatly. Now again, function I mentioned with some make adder of some x. Inside of this function, I am using some return function y and return x plus y. Now look at this. This is what the nesting subprogram, right? In this nesting subprogram, closures I can implement. How can I implement a closure? I can call closure from any arbitrary place. So I am calling closure from here. As soon as I call this, because I told you it is a subprogram, when subprogram is being called, now wherever you implemented that subprogram, it will give response. Now we were calling here add 10 of 20. Now it will be switched to this function make adder of x. X is what we were having 10 because here make adder parameter value is what? 10. Now if you come down, there is y value also. Y value is what it will be passed with this parameter and which is of 20. Now x plus y is, x value is 20, y value is, x value is 10, y value is 20. That's the reason why output of this segment will get displayed as 30. Fine. Now, so this is also closure. You might not seen this kind of representations in any of the language. So it is the only thing which I can use with the closure. Closure can be called in any arbitrary place. Closure will not have any parameters like that. I cannot write here a comma b. No, I cannot write. I have to write only this values. If you are passing some kind of variables over here, make sure the variables are already given values top of the statement. Fine. So this is what the fundamental idea about the closure. Now let's talk about the coroutine in detail. Coroutine is what? It is also a subprogram and it can have multiple entry points in the program. Coroutines can have multiple entry points and which are controlled by the coroutine themselves. They also have the means to maintain their status between activations. The mean of this is, I can call, let's see that there are two subprograms A and B. Now A, while I am executing A, I am just using resume B. Resume is a keyword to use, it is a coroutine. Fine. Now resume B in the sense, we will be resume the operations of B subprogram. Now this is what coroutine. I can write, now let's see, it is what? Resume A. Now when you wanted to compute resume B, we started with the A first of all. Now we were in A subprogram. There is an instruction resume B, that means one coroutine has initiated. So after you initiate this coroutine, we will be, as it is a subprogram, we will be switched to the resume, we'll switch to the B subprogram. In B subprogram, there is resume A. Now we'll again back to the A to resume the leftover operations. Yes. Now this is what the multiple entry point justification, and activation of this coroutines will get activated by itself. Right. Now this means that coroutines must be history sensitive and does have static local variables. Secondary, executions of coroutine often begin at points other than its beginning. Because of this, the invocation of a coroutine is called a resume rather than a call. We won't say it is call, and that is the other difference. In closure we say it is call. In coroutine we say it is resume. Now let's look at even the sample segment. Sub CO1, sub CO2, sub CO3. The CO is what? Coroutine. Now once after I entered into inside of this subprogram to evaluate or to execute, after I have been executing all these instructions which are top of this one, so I can go back to the CO2 to resume the operations. And after, so the mean of this is what? We'll switch to the CO2 where it was written, and we'll again switch here with the resume CO1. Fine. So once after you evaluate all the kind of instructions, as you have instruction to resume CO1 back, again this resume CO1 will get executed. We'll go back to the CO1. Now find after you are evaluating again CO2 you have to write, because we were switched from CO2, right? And we'll come to here again. And there are instructions which are executing. Now find CO3. Again CO3, it will get operated. CO3, and will execute many instructions whatever we have here, and here again from where you got from to that you will switch. That means resume back to CO2, then again we'll go back to this one CO1, again we'll go back to this. So this is what the way of executing or the way of using the resumes, that means of coroutines in the programs. Now let's see. A coroutine is a special kind of subprogram, the characteristics we just gathering. Rather than the master-slave relationship between a caller and a called subprogram that exists with conventional subprograms, caller and callee coroutines are equitable. In fact, the coroutine control mechanism is also called as symmetric control unit, symmetric unit control model. One of the usual characteristics of subprogram is maintained of coroutines. Only one coroutine is actually in execution at a given time. Although there may be only one processor, all of the executing programs in such a system appear to run concurrently, and this is called as quasi-concurrency. Now let's see how coroutines will get evaluated. Now let's see about two subprograms. A and B subprogram. In this A, assume that there are other instructions what I have wrote. So once after you find with all the instruction execution of this part, we will be executing this instruction. Look at the instruction. It is resume B. Now we will be switch or else. That's what we were mentioned in the previous slide. It is rather than the master slave relationship, we will be having called callee relationship. Now A is the subprogram which is resuming the B subprogram. Now we will be switched to B. Now we will execute some instructions over here. And again you find here resume A. So we will be back to again resume B. Now after this, we will come this side to execute all other instructions. And again you find here resume B will resume to the same. From where the control has been shifted to that control back will be given. And that's what the caller callee statement procedures. Now resume B, we were again going back. Now after you execute few more instructions, you find again resume A. Now where will we go again? We will go to the where you left the control. We were left control at resume B, right? And again control will be back to resume B. Now after that, we'll execute few more instructions. And now we'll be finding resume B. Find resume B again, we'll go back to the resume A. And we'll do some more instructions here. So these kind of coroutines are being initialized in the programming languages. And so you may ask a question, why A should start the B? Why not B starts A? Yes, quite natural. So this is what actually we say, master-slave relationship always is possible with two ways. That means A can start with the executions to resume B, or else ulta can also be possible. That means now we'll take the other part, that here A and the same structure we'll take and we'll do some reverse order. That means now B will start the execution. In the previous one A started it, now B starting it. Now once after B starts it was, now I'm just giving resume A. Now control will be given to resume A to execute the instructions. And once after you started with the execution part, if you find again resume B, control will go back to the where you left the control. Now again resume A, and it is not a recursive call. It won't happen repeatedly. It takes only one time execution. That's what we were seeing. It can have multiple entry points, but at a time it executes only one coroutine, one resume function it will. Now after you come to resume A, we'll have some more instructions here and we'll execute the other instructions. After you execute, if you find again resume B where the control shifted this statement, again we'll go back to this statement. So after that we'll evaluate some more instructions. Fine. So this is about coroutines. Basically coroutines will do two-way structure. Master-slave structure. See, master-slave matlab, see from this to this only you will be having, you never come to from this to this. But it is not master-slave. I am just showing you the way how relationship is getting existed. So we'll be having two-way structure. A will resume B, B will resume A. So this is about coroutines. Thank you all.